thank you very much. Good evening. And I don't for a minute claim to know anything about agriculture. I used to keep a garden, and then the deer won. So that was that. But I love talking to people from different sectors that we serve in the State Climate Office, and Rutgers in general serves, be it transportation, utilities, emergency management, agriculture, and beyond. I only wish I had more time. I was asked earlier what I like better, doing my research, the State Climate Program, my teaching. And I said it depends. If the one I'm doing I like the best. Especially I go into class, I can forget about proposal writing and budgets and everything for a little while or whatever. But I really do enjoy the State Climate Program. I've had the opportunity to be State Climatologist for 27 years now, which makes me, as of this past June, the longest serving State Climatologist in the nation. I don't know if I like that, frankly. I'm going to be a grandfather for the first time later this year, too, so this may be too much to take. I've had the opportunity. Iowa's State Climatologist retired, if you wanted to know, and he had been at it 3 more years than me. But this was kind of what I would have wanted to be when I grew up, as a weather climate geek up in Bergen County. Not many farms there, although my parents grew up when Paramus was onion fields, and in Secaucus there were a lot of pigs, and I would hear stories about that. Yeah, it's a real pleasure to be in my state at State University and have the opportunity to do this. It is a position appointed by the Dean of the Agricultural Experiment Station via a decree that Brendan Byrne wrote in 1979 after the feds pulled out of the State Climate Program in the early 70s. It evolved mostly at land-grant universities, and now we have a nice national organization, mainly of state climatologists at land grants and some state agencies as well. And we've hosted the national meeting twice, as recently as a couple years ago down in Cape May, and myself and my predecessor have each had the opportunity to be president of the organization. So that's a little bit about that. I can tell you about the geography side of thing another time or whatever. And I was telling at dinner, my research, which you guys don't want to know much about because it's the wrong season, I study global snow cover. I'm kind of the go-to person on global snow cover in another life outside of the state climate. So this is what we want to get through in 30 minutes or so, and I want time for questions. And then if you get bored, head off, and I'll talk to others as much as you'd like to ask questions. So again, a little bit about the State Climate Program. I've already kind of introduced myself. It's a small cadre of folks. My assistant gets some support from the experiment station, and then the rest of my crew, which there are about 10 of us this summer, are sponsored off contracts and grants that we have to go out and get, which is common at Rutgers and other universities. Kind of our credo, and what I've built this program to be, is we help decision makers. And kind of our credo is locals trusting locals. We work with Regional Climate Center, as the Mounts certainly know, and we work with national centers. But when it comes to making decisions in all different sectors within the state, including ag, you know, it's nice to be able to talk to a local, we think, and work on a problem together, because we know your territory a little bit, and we know what you might want, but we can't tell you that, but we can work with you to develop products or give you data that could serve your needs. This is our website, njclimate.org. Real simple. This is the picture that leads the narrative that Jess was talking about that just got published this week for September, which would tell you that it was the 3rd warmest September since 1895, and the tied for the 6th, however you look at it, 6th or 7th wettest in that period as well. What did I do? I just turned it off by hitting the wrong side. This is something you can find if you go down the page a little bit. I thought this might be of interest to you. We do 12-month plots of temperature and precipitation anomalies, so you can just get a quick glance at looking back. This shows you temperature departures. Anything red has been above normal from last October through this past September, right here, and these have been below normal. So we were cold in March and April, but we've had the second warmest October. Mind you, this is since 1895. The last 12 months have had the second warmest October, the second warmest February, the fourth warmest May, and tied for the warmest August. And it was the third warmest September. So the top five, 1, 2, 3, 4, 5 of the last 12 months have ranked in the top 4 for warmest on record in New Jersey. This is precipitation. And this is the favorite graph of DEP when I sit on the drought monitoring board. I'm the lone academic on that board when things get real dry. I think I need to hide anonymity there, or some people might want to hang us in effigy or hang us completely when things come drought-wise. It hasn't been that bad since you guys would know. The last time New Jersey had a drought emergency, 2002. We've had warnings since that, watches since that time, and I've had to testify at multiple drought hearings which would go to warning and emergency, but it seems like they go and hold a hearing and it starts to rain. So it's really quite effective. But you can see, you guys all know how wet February was. It was also the second warmest on record, because what was the warmest February? Last year. It was only the fourth time February was warmer than March in absolute terms. It's happened 4 times in the past, 60, 82, 2017, and 2018. And in the last 2, it's because February was so darn warm. The first 2 is because March was so darn cold. And then we had the snow in March. And then you know how wet May was, I guess, when you were trying to get out in the fields. Jess was telling me. June gave a bit of a reprieve, and then come mid-July on, nothing but rain. Nothing but rain. And what besides the rain and the heat? The humidity. And what does that tend to do to the temperature range in the course of a day? The highs stay pretty high, and the lows way up. In fact, September, the average high temperature in September ranked like 25th. The average low temperature was 8 degrees above normal in September, and not only ranked as the warmest, but beat the previous record by 2 degrees, which is like shattering. It's like hitting 100 home runs in a season. Big time. So, you know, there's been a lot of stories with it, but that's what helped keep the night times up, which I'm sure doesn't help you. And it doesn't help people in urban communities either from a health side. We have a weather network, which you might be familiar with, some are. It's njweather.org, but you can get to it off the other site. This is something we built, sort of build it, they'll come. And it got pieced together. Unlike New York, which got $20 million worth of Sandy money from FEMA to build their network, I started with $80,000 from DEP, and we now have 65 stations roughly around the state, and every 5 minutes they'll record data, and here's maps that we produce every 5 minutes. This is what a typical weather station looks like. We have a variety of them, but this is over at the Watershed Institute up the road here, put in cooperation, wonderful cooperation with Jim and others at the Institute. And it measures, this station has a pretty full suite of variables. We don't do soil there because it's over their settling tanks. And we have very few snow depth sensors out there, but air temperature, wind, humidity, dew point, precip, pressure, solar radiation. And we have soon to have 10 stations around the state that measure soil temperatures and soil moisture at 5, 10, 20, and 50 centimeter depths. We power them by a solar power. We have cellular communication, so I get a nice fat bill from Verizon Wireless each month. I can't convince them to donate the bill. And then they go change from 3 to to 4G from 3G, and we need about 2G for what we pass through. But we have to go out and buy 4G modems now. So there's another $40,000 I've got to find this year. I mean, my advice to people who want to have an operational weather network is don't do it. But I love what it provides. It's just, you know, during Sandy, we had 52 stations at the time. We never had fewer than 43 reporting every 5 minutes. We lost one anemometer, blew off its mount at Harvey Cedars. That's it for damage. And the cellular stayed up. The Rutgers Computer Center, where our servers are, was on diesel generator power. And we were able to feed data to the Weather Service, to the governor down at Emergency Management Headquarters in West Trenton, the media, throughout the entire storm. So I'd still brag about that. But it also, a lot of things worked right and didn't fail. So that was one of our coup de grace. This is the page for each station where you can get current conditions, some past conditions, a track of the last 24 hours of temperature there. This is National Weather Service forecast. I want to make it clear, we don't forecast. This keeps us out of trouble. We use National Weather Service forecasts on our site, but we realize people sometimes want more than just the conditions. They want to know what's coming up. We also have a volunteer program of weather observers. Any CocoRa's observers in the room? CocoRa's, I didn't make it up. It's a national program out of Colorado State that's national in Canada and the Bahamas now. We have a group of volunteers. It is one of the biggest citizen science observing programs in the nation. There's some with phenology you might be aware of, and water quality and such. But we have about 300 active observers in New Jersey, and about 100 of them miss fewer than a week worth of reports every year. So it's just an amazing group of volunteers. And it's just a simple $35 rain gauge put up on a post. You go out in the morning and read it, go online and enter your data, and bam, it's out there nationally. It's archived at the National Climate Center and so on and so forth. I just happen to have a bunch of brochures with me tonight about it. These are maps that we produce. We're the only state where we do our custom maps. And here you can see it's a summer showery pattern. And here we are over here. Some heavy rain fell here, here, and here. It didn't rain in farm country down the southwest on this one day in 2016. This is today's map. The people who submitted data at 7 a.m. today for the previous 24 hours. Anything in pink is more than 2 inches. And anything in orange is more than an inch. The state got soaked. This was from the cold front yesterday, midday, and this was mostly the northern remnants of Tropical Storm Michael that came in overnight that gave wind gusts of in the 40 to 50 mile an hour range all up the Atlantic and Delaware coast at our stations, and High Point actually today had a 58 mile an hour gust. We have a station right up at the monument there. But a number of these are at farms, Rutgers farms and other farms around the state. So that's, but these CocoRa's observers are from all over and all ages, all walks of life, and they're just wonderful, providing the type of data that fills in the gaps that our electronic station just simply can't. So anyway, that's kind of the sales pitch, but I hope you would be interested in being involved with using our information or even becoming potentially a cuckoo for CocoRa's is what they say. But if you're interested, but as I said, it's there. If you can, you don't have to contribute to look at the site. You can just go right in there and look at it and see what fell in your neighborhood, rain-wise, and it's only on precip for the CocoRa's. So let's go. One slide on the global climate system. It's complex. So now we're going to segue into that. It's got all kinds of spheres interacting with one another in a system that has no beginning or end. Be it the lithosphere in the ground or the hydrosphere, the oceans and rivers and lakes, the biosphere, you know so well, and the atmosphere, can't forget that, and my favorite, the cryosphere, be it snow, ice, glaciers or ice sheets. And of course, it's all powered by the sun, and it's all moving at different paces and different time scales. And it all comes together and makes for a habitable planet where we can live and where water can exist as in ice, liquid, or vapor form. So it kind of works. The tuning gets adjusted from time to time, as we'll talk about in just a few minutes. But all of these components cannot be looked upon as independent cusses out there, including the center spot here, which is human activities, which has begun to play a major role in the global climate system. So that's your 101 course right there. Let's look at New Jersey's weather and climate. We have a diverse climate for a pretty small state because it has a variety of different components to it, landscape-wise. There's an altitudinal component where you get, some of the higher, we can't call them mountains, they'll laugh at us in most other states. We have hills, tall hills, but they have their influences, and the valleys, which you all know can be so important when it comes to cold air drainage. We have the urban corridor, if you will, the tweener zone between the hills and the coastal areas and the southern plains of the state, coastal plain. I call this the banana belt, should be in yellow, I suppose, which is inland, except right down near the bay. It's inland, it's lower elevation, and it's a little further south, a couple degrees latitude to the south, which can make a difference. When it comes to surface conditions, yeah, we can talk about urban versus rural, but the pinelands have their own special surface conditions with the forest and the sandy soils, which drain so readily. And you can have huge ranges from day to night temperatures there. And you can desiccate the region very quickly because of the sandy soils, which leads to the fire threat. But the soils aren't very rich, but the cranberries love it. And then, of course, there's the coastal sector, which is the great modifier, the water content, the ability of water to modify temperatures or keep them relatively stable, the heat capacity of water. So we have cooler springs, but milder falls. And when it all comes together, we look at our stations every year, our weather network stations, and there's times when we don't get the first freeze down along the coast until Thanksgiving. And meanwhile, in late September, we've had freezes in the valleys of northwest Jersey or even out in parts of the Pine Barrens. This year, 43 is the coldest temperature we've had in our network so far. But I tell you, by this time next week, we will have had a freeze somewhere, I think. Today was the first day of fall, right? It's about it. But oftentimes, the length of the growing season differs from the southern coast to the northwest valleys by over 100 days. 100-day difference in the growing season across the state. And that's in part due to land-water contrast and also due to the altitudinal variations in the northwest part of the state. As you well know, we're a precipitation-rich state, some years more than others. I love to get my students, and I always tell them I'm going to ask the question on the exam, what's the wettest month of the year in New Jersey? July. April's one of the choices, and they usually get it, so welcome to my class. The driest month? February. Now that's cheating because it's got 10% fewer days than some of the other months. But it tends to be a little drier. The air is colder. It doesn't retain as much moisture. July, the air is moister, warmer, so it has more moisture, and you can get those gully washers out real quick. It doesn't rain all day, as you well know. I mean, I tell you, who relies on the weather more than farmers, pilots, and mariners? They're the people you want to talk to about the weather. But I often say you have to look at the whole water budget. And the evaporation rate, if you put your pool out there, or your bird bath or whatever, is 7 or 8 inches in a July. So there's a net loss of water. So thank goodness it's the wettest month because it keeps the deficit from growing too large, except in your driest of summers. You get into trouble real quick. But I like to say you can play in the mud in the winter when it's not frozen, but you're not going to find mud too often in the summer, except this year. Everyone just kept telling me about all the mushrooms on their lawns this year. Sometimes we have too much, and you well know that, bordering the Delaware here in Mercer County, the floods of 04, 05, and 06 on the Delaware. And they had nothing to do with the floods of 99, 07, 10, 11 on the Raritan and the Passaic with Floyd and Irene and some nor'easters. We've had an awful lot of river flooding in New Jersey in the last 2 decades. But not just there. This is the flood of record on the Delaware, unlike Floyd and Irene and up in the Raritan. The great flood of 55 after Connie and Diane came back to back. But anybody who farmed that year must have been nuts, going nuts, because that was preceded by the driest July on record. And along came the wettest August on record, and both of them were record warm. So that was just had to be a crazy season to grow anything. I thought you might like this. It's not an eye test, but I just looked at the numbers that for Mercer County precipitation for the year to date. These are our CoCoRaHS observers amongst about 15 in the county, but these had what I think are complete records, or very close to complete records. So you see in the 50-inch range in Ewing, everywhere, except Hopewell, a 58-inch reading and a 52, Pennington 51, Princeton near 51. Our WeatherNet stations, we have one I mentioned in Hopewell. We also have one in Hamilton. This is 49 inches at that Hopewell station. Now in Hamilton, we don't have a heating tipping bucket rain gauge, which we have to use our automated site. So I missed, not only did we miss the snow liquid equivalent, I missed a parentheses there. So that's why that number's low. There's an official National Weather Service cooperative station you may well know about, Lee's Turkey Farm in Mercer, which goes back well over a century. And they've had 52.87, and there we've had a long enough record, so that's almost 17 inches above normal for the year so far. And you can see all of these have already exceeded the annual average with 3 months to go. And then you've got, this is an estimate from the Weather Service Flood Forecast Office, which is also looking at the year so far, and we're a foot above normal for where we should be right now, more than a foot. Of course, sometimes we have too little. 2010, you may remember, was the hottest summer on record, and it was also pretty darn dry, and that was a pond in August. This was over in Hillsborough, near my place at that time, and not very healthy. I was just marveling at how green everything was driving over here tonight, and it's been that way all summer long. You may be cursing the fact it was that green all summer long. But we've had dry as well. That is the Delaware River bed during the great drought of the mid-1960s. The river's over here, or the stream, if you will. That was the drought probably the last 500 years, according to tree ring records, starting in 60, depends how you call it. But the worst was 63, 64, 65. Started pulling out of it in 66. I really would not, I'll hope that I'm well retired before the next state climatologist would have to deal with something like that. And of course, we get a wild variety of weather. We do get some hail. That's a golf ball, and that's the hailstones. That was right outside my Livingston campus office over in Piscataway about 10 years ago. I was amazed my car didn't have any dings in it that afternoon. So we get a wide variety, even occasional tornado, water spouts. And this is Spruce Run Reservoir in 2002. In March, it was half empty. It should be full in March. And it loses usually about 30% plus capacity during the summer with water use. So we're talking about it potentially sucking mud out of there later that summer. But we had enough rain and we began to pull out of the drought about that time. A drought that had pretty much begun in '98, interrupted by Floyd briefly and a few things. But that was 3 out of 4 months in that period were below average. I'm looking for head shaking, some memories in some cases. Of course, we have other things, other events. Sandy, a transformative event in the annals of New Jersey from every aspect one can imagine, although I suppose not as much in the agricultural sector as many other parts of the state infrastructure and sectors. Another shot of Sandy. I gave a lot of interviews and a lot of talks about Sandy, and I've written book chapters on it and all. So let's look at climate variability and climate change. First of all, I don't like to break it into this is climate and it's the long term at time scales that we can't be held accountable, and this is weather where you get instant gratification or condemnation. It's a continuum. So when we're talking about variability, and it makes it very difficult, but I think it's important to think about that. So when we're talking about change and variability, we're talking about year-to-year change that might affect some of your crops, or longer-term change that might affect the fruit trees and other long-term planting in agriculture, rather than sectorize it into weather and climate. NOAA did that, and I sat on NOAA's advisory task force for a number of years, and we said, don't do that. And they learned their lesson, and now they're doing more of that continuum. That in terms of even modeling, the Europeans didn't have that schism, and they've worked together and made better models because the meteorologists and climatologists work together. So I wanted to preface it with that. I thought I'd also show you just some recent things to get you into that mood. This is summer of this past summer, June through August. Anything in red, it was warmer than the long-term average, and anything in dark red is the warmest summer on record. And you may be aware in Northern Europe they had wildfires, forest fires north of the Arctic Circle. It was so warm there. A couple cooler areas, this real cool spot in the North Atlantic, which we think is associated with excessive ice melt off the Greenland ice sheet that is flooding over that area and affecting the thermal characteristics of the North Atlantic. But you're hard-pressed to find a cool spot. This is New Jersey summer warmth, and this is something I think may really hit home for you. These are the 15 warmest summers in New Jersey since 1895. Anything in yellow has occurred since 1999. 11 of the 15 warmest summers in New Jersey in the last 124 years have occurred in the last 20 years, including 2010, 2016, 2005, 2011, this past summer. Then you go to 99 and 12 and 02 and 06, 13 and 08. But there is natural climate variability, and there always has been. So in that mix is 1949, 1988, the aforementioned 1955, and 1973. And this makes it a difficult issue for everyone to deal with because we live locally, we live in an anecdotal kind of personal space, and on top of all of that, we have natural weather and climate variability, and from all of that, we're supposed to sort out a signal on whether things are changing and then why they might be changing. So it makes for a difficult equation which really can stymie people unless they read about it, listen about it, learn more about it. These are global temperatures going back from 1880 to 2017. The 3 warmest years since that period of time have been the last 3 years globally. This year is going to be 3rd or 4th. So it's going to be the 4 warmest years, 15, 16, 17, and 18. This is data gathered over oceans, over the continents, and pulled together from NOAA. So this is the global picture. This is the Jersey picture. It has a little more year-to-year variability. 2012 is the warmest on record. And we've gone up and down a little since then. but your coolest years in the last couple decades are as warm as your warmest years were the first 70, 75 years of the 20th century. This goes back to 1895 here. So I tell my students they have not lived in a same climate world that their parents grew up within New Jersey or their grandparents. It's just simply a different world. I've told my college seniors the last 4 Septembers of all rank in the top 10. I said, you haven't been on campus in the fall to start school, not thinking it's still summer for the first month. It's just these profound changes are occurring, but they're subtle and they're year-to-year variations. And you know, you folks being out in the field may appreciate it more than many, many others because your livelihood depends on it, and you're out there experiencing it as well. But it's difficult. It is, on average, only a couple degrees, three degrees. This is 55 degrees right here, and this is 50 degrees here. So these ranges are 5, 6, 7 degrees in annual temperature. May not seem like a lot, but when you average that over 365 days, it's pretty notable. I just grabbed this. Actually, my assistant Matt grabbed this while I was out of town this week. These are growing degree days with a base of 50 at Heightstown at the co-op station from 1940 on. Some missing data early, including the first year. And you can see a lot of year-to-year variability in growing degree days, but notice how it's ramped up in the last 20 years or so in terms of growing degree days. This is from the National Climate Assessment back in 2014, the increase in frost-free season length. You're going 10 days longer between your last freeze in the spring and your first spring freeze in the fall. But it's even more pronounced in the western part of the nation. You have to sit back, and who better to give this to as you folks. You have to have a little humor in here as well. Precip, so vital to your livelihoods. Tremendous variability from year to year. There's the drought of the 60s. This is annual precipitation in New Jersey. I should say this is averaged from a couple of dozen stations situated all over the state. It's just not 1 or 2 places. 2011, thanks to Irene and a nor'easter in March and others, was the wettest by far. And then we go up and down. The one thing I find most interesting here is if you look at the interannual variability here, and then since the 70s, you have more interannual variability, which I claim if things are going to change, you'd almost rather they change in one direction so you can kind of adapt in that direction. But if you have to adapt in both directions, years where it's too wet and then years when it's too dry, it makes it even more difficult. And that's one thing I've noticed with the Jersey precip record is the variability from year to year has increased over the last couple of decades. So that tells you that climate is changing. I can show you my snow cover work. I look at sea ice in the Arctic now that I started looking at as a college intern. I never thought in my life I'd see so much open water in the Arctic in the summer. To me, that's the canary in the coal mine. It's amazing. And snow cover I monitor, I've been publishing since '90. I was the first to talk about the demise of snow cover earlier in the spring. It's just leaving weeks earlier in some cases than it was 50 years ago over the middle and then high latitudes as spring goes on. But that doesn't say why. And I realize it gets a little controversial when people have to just kind of attribute it to something because, as I said earlier, the climate naturally changes. So how do we extract a signal of change that we might attribute that humans, since about the late 70s and early 80s, are the major cause of the changes that have been observed across the globe. You still have interannual variability. You still have Pinatubo erupted in '92 and brought temperatures down for a year, but the models show that they would have come down a lot further if we hadn't had greenhouse gases polluting our atmosphere. So, and that is the greenhouse effect. This is a natural phenomenon. You have to realize that the Earth only receives enough energy from the sun to warm us up to 0 degrees Fahrenheit without an atmosphere. That's all the energy we get from the sun. So we have an atmosphere with water vapor, the primary greenhouse gas, carbon dioxide, methane, natural quantities, that allows the Earth to have a blanket of an atmosphere around it. And because of that blanket, you get the solar radiation in. Now you want to get it back out, but it has a little difficult time getting out. Thus the arrows are a little thicker because it tries to radiate energy out. It gets absorbed by these greenhouse gases. They send some of it right back, and you've got this ping pong game, and occasionally the ball comes off the table and goes up in the atmosphere, and you hopefully get a balance of in versus out being equal. It's not equal these days. More is coming in than is going out because we've thrown another blanket on the bed. I mean, think about it. You're cold at night, you put a blanket on you. And that keeps the warmth of your body, in this case, your body heated internally, not from the sun, but keeps that warmer. But you don't burst into flames at a certain point of the night because all the heat's held in. Eventually, you'll get as much heat out on top of the blanket as you're producing, but you'll be warmer because the heat will stay near your body longer. If you're still cold, you throw another blanket on the bed, and it gets you a little warmer. It keeps the heat in there a little longer. And that's what we as humans have done. We're putting another blanket on the bed to warm what is naturally brings the Earth's temperatures from 0 degrees Fahrenheit to the upper 50s Fahrenheit. We're throwing a thin blanket on the bed that is warming the planet further. And about 90% of that warmth is being transferred into the oceans and held by the oceans. About 10% is warming the atmosphere. So there's a heck of a lot stored in the oceans now. So if we cleaned the carbon dioxide out of the atmosphere, it would still be getting warmer because of all the heat in the oceans. So, and then we have these models, and we run the models, as I said, and we run them with natural influences and then natural plus human influences, and they diverge in the late 70s. You can't tell them apart up till then. Once you get to the 70s, the only way you can explain the warming we've had since the 70s is to put the human element in there. Otherwise, the models without the human element just keep temperatures kind of steady instead of the rise that we've seen they've had. So anyway, that's the whole climate picture with attribution. What does that mean? You know, you're like, all right, that's what's happened, that's what's happening, but what's going to happen in the future? And that's when we turn to the models. As they're not perfect, you see a lot of variations when people say it might warm 4 degrees or 8 degrees. Well, how come they can't do better than that? Partly it's a function of the models and all the feedbacks in the climate system. Partially it's because we use different scenarios for the future in terms of how much greenhouse gas is going to be there. Some would be business as usual. We're just going to go upward trend. Others, we're going to clean things up and lower those trends. So when you see these ranges, it's a function of the model variability, but also the initialization of the greenhouses gases that are going into it. But all of them point to rising temperatures for New Jersey in the future, steady or increasing precipitation here in the Northeast, more energy in the system, so more variability, more extremes of storms, of flood, of drought, of heat. And then along the coast, the sea level has already risen about a foot in the last century, about 2/3 of that due to the climate change effects, rising even further. This is from the National Assessment in 2014. It essentially looks at model runs from the last 30 years of the 20th century and the middle 30 years of this century, just 20, 30 years from now. And they difference them. And everything in red or yellow or orange is warmer the middle of this century compared to the end of last century, everything in blue, it's cooler. Yeah. And these models begin to be able to look at seasons, and kind of the scary point there, it shows the greatest warming compared to the last part of the century by the middle of this in the summer, in the growing season. Then they did the same thing for precipitation. These areas are wetter, these areas are drier. And you go, so yeah, they are dry. No, that means that the dry areas get drier. I don't know if you want to move to Arizona or Southern California. And for Jersey, you can see a little bit of getting wetter, particularly in the winter, but look at the summer. It looks like hotter, drier, or maybe the same precip in the summer, but milder, wetter winters. So these are the latest generation of models suggesting that. So we're on the home stretch. Few things on impacts and actions. This is where I get a little off my home turf. Impacts of climate change, and right there, agricultural impacts in yields, irrigation demands, growing season length. I like to say with growing season length, careful what you wish for. And you probably know exactly what I'm talking about when you have a warm March and along comes a run-of-the-mill late March cold spell, and you're up all night wondering, what was it, a couple of years ago? We had that really warm March, and a cold wave came in, and it got a little windy that night, thank goodness, and it kept the temperatures in the mid-20s instead of the low 20s, and I was told that saved most of the fruit crop in Jersey. They weren't so lucky further south in southern states. So ag, health, forests, water resources, resources, and on and on. Anything we should do about this? This is my one preachy slide. Not this slide, the next one's coming up. But this does say, our plan involves horses and men. First of all, I call it challenges requiring attention. And again, this is my opinion. I have to say it with Brian here. It has nothing to do with Rutgers' opinion on whatever, but knowledge. This is where I think State Climate Office has to come in and do the most. This word understanding. I've been speaking to you probably too long already. You haven't heard the word believe out of my mouth, have you? There's nothing about believing in climate change. People say, you believe in climate change? I say, no, I understand it. And it's not semantics. You may want to argue with me. We'll talk offline. But it's not. This isn't a belief system. I'm a scientist. I want the facts. I want the theory. I want to put it all together and get a better understanding of what's going on. And, thanks for asking me tonight and sitting there and listening. Hopefully you're developing a little better understanding, ramping up what you already know. Mitigation. The train, I like to say the train's left the station. It's going to keep getting warmer, the climate's going to keep changing. But we can control the throttle a little bit. And one thing is through mitigation. We can reduce emissions, we can use less energy, and we can use cleaner forms of energy. But we're not going to mitigate ourselves out of this. I've been telling my classes that since I got to Rutgers, and it wasn't a very popular idea, but I just knew everyone wasn't going to walk home and turn off their furnaces or air conditioners. Adaptation. The word resilience is used a lot today. We need to be able to adapt, and you folks are probably the wisest of that when it comes to understanding things. And I realize a lot of your decisions are just made on a seasonal basis at this point. But for some of you, you have to think in the longer term as well, to be more resilient in the future. And then finally, some activism, some leadership. That just means going out there, raising the public awareness of climate and climate change. Encourage people to go and vote once they look at the candidates' platforms and whatever suits them and whatever they feel most is important. But just get out there and be active and look to leadership. The leadership in the climate world today is, in the United States, is being provided by cities, followed by some states, and then no matter what the political affiliation at the national level. It's not had leadership, in my opinion, at any level sufficient to what's needed. But the cities have really picked up some, and internationally it's become, there are nations that are recognizing things more than this country. So anyway, not to get political or to get too much into the social science, but this is a little bit of my preaching's over. Just to sum up, our climate's changing, temperatures are rising, climate's becoming more variable, the growing season is lengthening here in Jersey. There is a human fingerprint on this climate change, at least over the past several decades. We're primed for more change. The oceans and the atmosphere and the continents, they're all primed. You're not going to get a big storm all the time because you need a trigger. And if you don't have that trigger for the storm, you're going to be hotter, which is going to dry you out, and you're going to have drought. So you may not care for the triggers, but if you have too few of them, then you're going to get in trouble in the other direction. And it's going to keep changing. There's nothing to suggest it's not. Of course, self-serving, I like to think we need to still monitor and better understand. Sounds like a pure academic there. And do better prediction for the future. The more we know about what's coming, and with a greater level of certainty, the better off I think we'll all be. But as I said, don't give up hope. As I said, the train has left the station, but we can still, through mitigative and adaptive actions, slow the locomotive, or at least be able to handle what the climate system is going to be serving us. And with that, just might recognize, I visited and stole from websites generously, and I saw the commissioner with the jacket with that before and whatever. So thanks very much.